Welcome to this video on heat transfer. Now there are three main ways that heat can move, and they are convection, conduction and radiation. So let's start by looking at convection. Convection is the movement of heat in a fluid, and by fluid what I mean is liquids and gases. They're both described as fluid because they flow. Now if I were to heat this gas up here in this diagram, the particles would get more kinetic energy. They'd move around a lot faster. So what's going to happen to the amount of volume that these particles occupy? What's going to happen to the space that these particles take up if they start dancing around really, really quickly? Well, they're going to take up more space. Once they're moving around very, very fast, they're going to take up a lot more volume. So what happens is we get the same mass, the same number of particles. Mass is just stuff, number of particles. The amount of stuff hasn't changed. Six particles here, 6 particles here, so mass stays the same. But the volume increased because they took up more space, because they're jiggling around much faster. Now, what happens if the volume increases, the mass stays the same? What's going to happen to the density? Well, the density is going to go down. So what I'm saying is, when you heat a fluid up, the particles dance around, they take up more space, increased volume. This gives you a reduced density. Now, less dense things float. Less dense things move up when they're surrounded by more dense things. Okay, so we've got a nice demonstration of this here. We've got a beaker full of water and we've got some potassium permanganate in there to colour it. You can see a little convection current moving up there. So what's happening, there's a candle under here and it's heating the water up. Those particles are vibrating and start to take up a greater volume, so they get less dense. Less dense than the rest of the water, so it rises up. Hits the surface, moves sideways, and then it starts to cool down. And when it starts to cool down, it becomes more dense and it will begin to sink down. And you get what's called a convection current. So we can get air currents in our houses too, convection currents. Hot air from this radiator rising up, moving across the ceiling, hits a cold window, cools down, becomes more dense, and then sinks and goes across the floor, and we get this nice convection current building up. This is one reason why it's not a good idea to have your bed next to a window, because what will happen is the cold air will flow over you during the night as you sleep. Right, conduction. Conduction is the movement of heat through a solid. Now, metals are very good thermal conductors. Non-metals and gases tend to be poor thermal conductors. So poor thermal conductors are also known as insulators. So air, which is a gas obviously, is a bad thermal conductor and a good insulator because it doesn't allow heat to move easily through it. The mechanism by which this happens is you get these what are called delocalized electrons. In most materials, the electrons are stuck to their atoms. This plus charge of the nucleus holds the negative charge of the electron in, and each electron stays with its nucleus. In metals, this isn't the case. In metals, the electrons are free to move out and flow around. So we've got these delocalized electrons. And it's these delocalized electrons which will transfer the heat from the hotter parts to the cooler parts. Now, radiation. While convection and conduction need particles to move around, radiation, that's not the case. Radiation is a wave, and it's an electromagnetic wave. It doesn't need particles to collide with each other or space out or anything like that. It doesn't need electrons or anything. And this is fortunate for us because there are no particles in space, and so we need radiation to get the heat from the sun to planet Earth. And that's how heat from the sun reaches us, is this part here of the electromagnetic spectrum, infrared radiation or heat. This little thermogram here, you can see, this is taken with an infrared camera. Can you guess which colours are hot and which colours are cool? Well, in this picture, the white part is the really hot part. Then it goes to red, and then orange, then yellow, warm, and then we're down to the greens, and then the blues for cool. So this elephant's ears are cooler. So let's talk about emitting infrared radiation and absorbing it. To emit means to give it off, and to absorb means to take in. Now, some surfaces are better than others at emitting and absorbing infrared. Black is the best for both. Black is the best colour for absorbing it, and you're familiar with this. If you go out on a hot summer's day and you're wearing black, you're going to get hot. And the reason you're going to get hot is because you're absorbing all that infrared. Black is also the best colour for emitting infrared as well, though. It does give off infrared the best as well. Shiny or white surfaces are generally best at reflecting infrared, And this is probably why lots of houses in very hot countries are painted white, to reflect that infrared and cool down. Now, let's talk about insulating homes. How do we keep the heat in our homes and reduce the cost, reduce our bills? If we're paying money to heat our houses, we don't want that heat leaking out. This is a thermogram, and you can see, like we saw before, the hot parts are red and white. So the windows and the roof here are really hot. Why is that? Because the heat is pouring out of this house. So what can we do to stop this? Well, we can start from the roof. Really effective way of stopping heat loss, fiberglass roof insulation. The reason it stops it is because it's got air pockets inside it. Air is a great insulator. Heat can't leave through conduction because it's not solid, it's not all solid. There's a lot of air gaps in here, so it slows down the conductive heat loss. But also it can't leave through convection. Convection needs a big space to set up these currents. Here we've got little tiny air pockets, and that stops those convection currents forming. Double glazing. Heat loss through windows can be reduced using double glazing or triple glazing. The gap between the two panes of glass is filled with air, so heat loss through conduction is reduced because air is a poor conductor of heat, and transfer by convection current is also reduced by making this gap as narrow as possible. If it's too narrow, you can't get a convection current and you won't lose heat through convection either. So all these methods stop heat loss through convection and conduction. Same story here with cavity wall insulation. All external walls have got two layers and a gap in between, an inner wall, an outer wall, and this gap. And this gap is filled with a foam. And what this means is you've got pockets of insulating air. If you only had one wall, what could happen is the heat could leave through conduction, through the solid and out to the outside air. It can't move through conduction here because there's no solid between here. Most of this is gas, so that stops conductive heat loss. And again, just like the fiberglass, because we've got little pockets, we can't have a convection current set up, and we don't lose heat through convection either. Other ways of stopping it: draft excluders, carpets, closing the curtains, all of these things. They may not cost so much money, but they do have a fairly significant effect at stopping heat loss in your house. Right, let's finish up. Let's have a look at something called payback time. Now, this is how long you're going to have your double glazing, loft insulation, or whatever it is before you've paid off the initial cost. So let's look at a quick example. The double glazing for a house costs £3,000 but saves you £150 a year in fuel costs. What is the payback time? Well, you just plug these figures into this little equation here. So let's do that. Cost of insulation was £3,000. Saving per year, it says it's 150. How many 150s are there in 3,000? There are 20. So it's going to take you 20 years of savings to pay back your initial £3,000 cost. Now you might say, if you were only planning on living in that house for another 5 years, you might say, well, there's no point in me doing it because 5 years of £150, that's only going to save you £750. And you spent £3,750 saving. That doesn't sound like a good idea. But it's not quite that simple, because adding double or triple glazing to your house is going to increase the value of your house. So it's not quite as simple as I'm making out here. So that's it. That's heat transfer and keeping homes warm. Thank you very much for watching.